So hello everyone, welcome to another video, and in this video we will be doing basics of Numpy module, which is available in Python. So, and the IDE which we'll be using is the Jupyter Notebook. It is available on Anaconda Navigator and it is readily available. We're using this because it is simple for beginners, and yeah, it should be a little bit easier compared to other modules. So you just press the launch button here and it redirects you to your web browser here, and in this, to start a new file, we just go to notebook and python 3, which opens a new tab, and as you can see, it's in the computer itself as it says localhost. So here we can type our codes with regarding the Numpy, and let's change the title. Let's say intro to Numpy. Click rename. So we'll be doing this in this video today. I'll try to keep it short, but let's get into it. So what is Numpy? So it is basically a Python module. It is actually pronounced Numpy, which is NUM space PIE, and it is similar to pandas and other modules. So let's start. So you need to import the Numpy module first. Import Numpy and name it as whatever you like, but the general is import as np. And some basics about Jupyter is when you click enter, it goes into new space, but when you click shift enter, it executes it, and since it shows in 1, that means it's executed. So this module is ready for use. So what is Numpy? So Numpy basically works with Numpy arrays and indexing, and just for storing data in 1D 2D dimensions. So, and an array is like, it generally refers to a named group of homogeneous elements. So let's say if you want to store any numbers, say you have to store the natural numbers. So what you do is first create a list in Python, and the list is with square brackets, and mention the numbers which you would like to use, and then it's executed. So next we will do for the converting it into a array. We just use a simple command a1, we can take any name, is equal to np dot array, and mention the list which you would like to use it, that is this one. So when you click enter and say a1, it says array 1 2 3 4. Since a1 has been converted into array, it mentions array 1 2 3 4. But if you straight away print a1 as this, it will only show 1 2 3 4. So this is one thing, and as we can see, this is a one-dimensional array, and similarly we can create a two-dimensional array with the same, say we can do a2 is equal to np dot array, and we can directly write the list inside this itself. So for a two-dimensional array we need rows and columns. So in this, let's say 1 2 3 4, and we separate it by a comma, and then again we start say 5 6 7 and 8. So this has now let's print it. So a2, so this says that create from rag, which is a list of is depressed. If you mean, you must specify the object. Okay, so we forgot a comma here, so let's just put a comma. So this should work now. Yep, this should work out. So here we can see it has two rows and 4 columns, as we can see, and it is a 2-dimensional array. And in this the special thing is that we can also provide its indexing. Say you would want to access the number which is at 0, 3. So when you press that, you will get 4, because in the 0th row and in the 3rd column, so we can see it's 4. So one thing to keep in mind is that the Numpy indexing always starts from 0, so it goes 0, 1, 2, 3 and 0, 1, 2, both row wise and column wise. So we have to keep this in mind. And we can also find out the type of this. What is the data type? So we can do type a2, and we'll get numpy.nd array. And we can also find out what is the shape of it is. So a2.shape, we can do it that, and we can get it is 2, 4, as it has 2 rows and 4 columns. So this is just one way to create a 1D and a 2D array. We can also create a 3D array also by adding another separating it by another comma and adding another list. So there are a couple of things to keep in mind are that the main differences between Numpy array with Python lists. So unlike Python lists, once a Numpy array is created, you cannot change its size. So you have to create a new array or overwrite the existing one. And also comparatively to the Python lists, the Numpy consumes very less space on your storage. And also every Numpy array can contain elements of homogeneous types. That is, all of its same elements have one and only one data type, unlike Python lists where you can have multiple data types. And the direct vectorized operations are not possible. So if say that you, in the previous one, let's take list plus 2, so this will come with an error, because you can't concatenate using the list using a 2. So they are very different data types, hence you can't add them. And the Numpy works with the same types of data types. So the bool, the int 8, 16, 32 and etc. You can change it with the data type .data type, and by mentioning the data type which you want. And so next we can do is let's see a couple of more ways to create create an array. So let's say you want to create an array which starts from 0, so up to a certain number. So what we can do is array 3 is equal to np dot arrange, and we can say 7. So what it will do is start from 0 and end till 7. So let's say AR3. So that's what it's done. So, and once if we see the AR3.d type, we should be getting an int 32, because these are integers which it has taken. And we can also create an array using linspace. So a linspace is used when you need to you need to divide elements evenly spaced between two given limits. So for this we use linspace function, in which you have to provide a start, the end, and the number of elements which you would like. So let's say AR4 is equal to np dot linspace 2.5 comma 5 comma 6. So what this will do is it will start from 2.5 and go up to 5, and it will have 6 numbers in between, evenly spaced. So let's print it out. So this is what we get: 2.5, 3, 3, 3, 3.5, 4, and this will obviously be float data type. So these are just some of the ways you can create a one-dimensional array. And if you want to create a two-dimensional array using what do you call a range, so you can do that as well. Say AR is equal to np dot range. Say you want to use 10 and next what you can do is take another one, AR1 is equal to, or you can update the same one and say that AR dot reshape in whatever the row and column format you like. So let's say we want 2 rows and 5 columns, and let's print it out. Okay, this has okay, I'm sorry, we have to use range, not range. These are simple mistakes which happen. This is not a big deal. Let's type it again. Range 10 and AR1 is equal to AR dot reshape 2,5, and let's print it. So it has 2 rows and 5 columns, as just like we mentioned. And let's say if you want to have 5 columns, so you just invert it. 5 rows. Oops. Let's say you want 5 rows and 2 columns. In AR1 you will get 5 rows and 2 columns. So one thing to keep in mind is that the number which you choose in a range, say 20, 10, 20, the reshape has to be a multiple of that. Only then will it convert it into an array of 2D, a two-dimensional array. So, and you can directly as well, you can also say you can directly put it in a single line dot by typing np.arrange 10 dot reshape function and 2,5, and this should print the same output as the above, and there you go, gives the same one. So these are some ways to create an array, and there are a lot others. Say you want to create an array which is filled by zeros, so what you can do is AR is equal to np dot zeros and the rows and the columns of zeros you want. So this will print 4 zeros. This will print zeros in 4 rows, 3 rows and 4 columns. So this is it, and the data type is obviously, as we can see, it is float. We can change the data type nevertheless, so we can just say same, and we can separate it by a comma. Data type is equal to np dot int whatever you want, 64, 32. So oops, and this is okay, we forgot the equal sign. This happens, so let's go with this. and d type is equal to in64, which we can see the points are gone. So we can create it like this also, and we can do same with ones. If you want, say if you want to print once, so we can do that as well. Okay, and what does it say now? Forgot. So we should get once. These are just if you want to quickly get values, we can use this. And say if you want some random value to be printed, so you can do np.random.rand and mention the rows and columns which you would like, and it will do so. So AR, it will print any random values which it finds suitable. So these are just some ways to create NP arrays. And next let's talk about the indexing. So as we already know, the indexing always follows the normal indexing pattern in Python. So we can say AR is equal to np.array, and let's take 2, 4, 6, 8, 10, 12, 14 and up to 16 maybe. And we can start our indexing and we can work our way towards the indexing. So let's say if you want to index the AR to 3:7, so how it will do is that it will go to 0, 1, 2, 3. It will start from the 0, 1, 2, 3, and it will start from the next one as usual, the Python, and it will go up to 14, which is the 6th one, as there are total so 0, 1, 2, 3, after that it starts 4, 5, 6 and 7. So at the 7th it stops. Similarly, say if you want the indexing to take place from up to 5, so it starts from 2 and it will go up to the 5th index, so which is 10, 2, 4, 6, 8, 10. So these are just some of the ways in Python in which Python works. So what we can say is that it goes from 0 to m-1 in this case, and 0 from n, which is mentioned, n, to m-1, where n and m are the indexing values respectively. Let's take some more examples, such as AR. We start from -1, so this should print from 2 to all the way to 14, because we are doing reverse indexing in this case. So that's exactly what it does. And maybe we can do something like AR is equal to 2:7 maybe 2 again. So this should give you it will start from the 3rd one, because the indexing starts from 2nd, so it will start from 6th, and it will skip 2, because the step up number is 2, so it will skip every 2 numbers and it will go up to the 7th index place, which is 14. So it will print something like 6, 10, 14, and that's exactly what it does. So this is some this is you can consider this as 1D array slicing, So in similar way we can also do a 2D array slicing as well, which is a little complicated, but it is pretty easy so to do as well. So what we can do next is let's take an example of the 2D array then. So let's say AR is equal to np.array. Let's take a 2D array. So 2, 4, 6, 6, 8, 10 maybe, and the next one will take it as 12, 14, 16, 18 and 20, and the next we will go for 22, 24, 26, 28 and 30 maybe, and the next we will do 32, 34, 36, 38. So as we can see, this is an this will have 4 rows and 5 columns. So if we print it, okay, it takes 1 from 2 positional spaces, so we have done a mistake maybe here. 1, 2, 3, 4, yes, we forgot 40. So they have to be perfect squares, so you just can't put any numbers you would like. So now it should come out all fine with 20, 30, 40. Array takes 1 to 2 positional spaces, so array 2, 4, 6, 8, 10, 12, 14, 16. Okay, we forgot to enclose it in a full. Let's do so again. Again, just some rookie errors here and there, so that happens. So here we have 4 rows and 5 columns for the array slicing. So let's start slicing. AR, let's say we would like AR slice maybe 1:3, comma 3:5. So let's understand this with an example. So what does this do exactly? So it started from the second row and up to the third row. So it took this 2 first, and then it started from the 4th row and went up to the 5th row. So we can see the similar spaces are 18, 20 and 28, 30. As you can see, this for the 1:3, and this for, I mean this and this for 3:5. Same, so it follows row slicing first and then index slicing. So hence it took the common, which is 18, 20, 28 and 30. Let's take another example. Let's say this time we want to slice 1:3, the same, but we don't want to include any column slicing. So what this will do is this will only slice the rows and show all the column which are available. So this will go like this. It starts from the second row up till the third row, and since we did not mention any columns slicing, so it takes the whole column. Same case with, let's say maybe this time let's go with like this. So what this will do is this will do the same thing but opposite. So no row slicing has been mentioned, so it takes all the rows, and column slices have been mentioned, so it takes starts from the 4th row and goes up to the 5th, that is here, these values. So these are just some ways. You can also play around a little as well. say you want AR maybe something like 3 comma index -1. So this will print something like 40, 38, 36, 24 and 32. Yes. So why did it do that? It's because first we said that we want the third row. First we said we want the third row. I'm sorry, the fourth row. And then we said we want to start backwards, as we said -1 with step value. So it goes from 40, 38, 36, 34 and 32. So you can play around it with various ways such as -3. Let's take another example, and the final one, comma -4 and raised to 2. So what this will do is this will start maybe something like, since it says -3, so it will start something from here, and since it has the column has a step value of 2 and starts from -4 and ahead, so it will go from here, and as it has a step value, it will ignore the alternate one. So it will be 14, 18, 24 and 28. So 14, 18, 24, 28. As I said, it will ignore the every second one and print the third one. And since we said from -3 to -1, so it will go from here to here, 2 values. So these are just some ways in which we can play around in the 2D dimension. Nothing, no big deal. It is very simple. So let's come to a new topic, which is joining two arrays. So let's say sometimes you need to join 2 or more existing arrays. So for this purpose, Numpy makes available many functions. So in some of them are H-stack, namely horizontal stack, and V-stack, which is vertical stack. The second is concatenate. So we'll go one by one. So the first one is let's go with horizontal stack. So let's first create our lists because we have to add them. So let's say list1 is equal to maybe 1, 2, 3. List2 is equal to 4, 5, 6. List3 is equal to let's take a 2-dimensional this time, 9, 8, 7, and maybe 6, 5, 4. This should do it. And maybe let's take one last, just because why not, because we have to add all these. So let's take 4 maybe, and let's take another one which is 5 maybe. Yep, that sounds about right. Okay, so it says again we forgot this little here typos here and there, so these things happen. So let's get started. So let's first start with vertical stack maybe. So let's say something like sar1 is equal to np dot vstack, which is a numpy variable, and let's say we want to stack the list1 and list2. So say sar1. So let's understand what happened here. So we had list1 which was 4, 5, 6, and sorry 1 2 3 and list 2 which was 4 5 6, and we said we want to vertically stack it. So what it did is it as it said, it vertically stacked it, so it will come one below the other, hence making it 2 rows and 3 columns. So let's say if you want to know the shape of this, so you can say sar1 dot shape, again the same, you should be getting 2 comma 3. There you go. And maybe let's take one more example of 2 dot shape. This time I'm sorry, let's take sar2 is equal to np dot vstack, and let's do list 2 comma list 3. So okay, so it says unexpected EOF, again these things happen. So let's go with this one. So let's say if you want to print sar2, you'll be getting 4 5 6 9 8 7 vertically stacked, as you said here. And next let's go to the horizontal stack. So let's say we want to horizontally stack, maybe this time let's do list sar3 is equal to np dot edge stack list 3 comma list 4. So what this will do is horizontally stack, that is one next to another instead of one below the other. So you should be getting something like 9874 and 6545. So here we can see that 9874 and 6545 because we had them added side by side, that is horizontally stacked. So let's see. Okay, it says list 4 is not defined. Why does it say that? List 4 is equal to 4 comma 5. So okay, so maybe let's just do this again. 4 comma 5, there we said it, and now let's just copy this. Okay, now what does it say? All the input array dimensions for the concat must match exactly. Okay, so let's learn something from this. So you need to have the same dimensions for concatenation. So as we can see, it won't concatenate this because these both are different dimensions, hence this will not add list 3 and list 4. So this is another thing to keep in mind while doing this. Okay, and let's go to another one. and the next one, let's go to concatenate, which is just joining the arrays along axis 0, or which is the x-axis, or axis 1, which is the y-axis. In whichever way you want, you can specify it. So let's say you want to join, let's go with, maybe you want to join, let's take ARR is equal to np dot concatenate AR1, maybe let's take list 1 comma list 2, and we want to join them in axis is equal to 0. So we should be getting ARR, and this is joined, so 1 2 3 4 5 6, and we have joined it along the x-axis, so it just adds it right next to it. And let's say we want to join it from the below. So what we can do is axis, just change the axis to y-axis, and let's say AR. So and now it says axis 1 is out of bounds for array of dimension 1. So this time it won't add it because these both are in the x-axis, and to add you need axis in y, you need axis in 1, you need to have the columns, not the rows, hence it will not add them. And so these are just some basics regarding the Numpy module and various ways in which you can play around with it. And you may ask, what are the applications of this? So there are number of applications, such as let's say maybe covariance. You can find out covariance, and you can also find out the correlations, and also you can do a linear regression chart with this. So these are all just some of the applications of the Numpy. So let's take one of those applications, say covariance. So you may ask, what is covariance? So covariance is something like which tells us how similar varying two data sets are. So when you want to compare two data sets, you use covariance. So let's say a high positive covariance between two data sets means they are very strong, and means they are very strongly similar. And also a negative covariance of two data sets means they are very dissimilar. So let's take an example. Say A is equal to np.array, maybe something like, again, 1 2 3 4 and B is equal to np.array 3 4 0 comma -1 comma -3 maybe. And just go with this, and then we can take maybe something like cov underscore mat something, anything, which is equal to np.cov, which is the covariance function in the Numpy module, and let's say A comma B, since we are comparing both. So when we say that, what does it says? Okay, 1 2 3 4 and okay, so we had a mistake here, so let's just correct it. So we forgot to add a 5, so let's do that. And now let's say we want the same, we want to calculate it, so what we will do is this, and say enter. And when we say cov underscore mat, you should get something like this, 2.5. It says 2.5, so it has a high they are very strongly similar. And this says -3.75, means they are very they aren't similar at all. And a high covariance means they are highly similar. So this is very useful for comparing very huge data types. We just took 5 variables and 1 row, but we can do so with a number of number of rows and number of columns. It just makes life very easy when we can just use this. to calculate the covariance. So this is just one of the uh, applications of Numpy. So hope you guys liked the Numpy tutorial. Although this is just the introduction, it is very good introduction to get you started with Numpy, and it is very vast and very important for Python and anyone who wants to pursue data sciences in the future. It's highly recommended. So thank you everyone. Thank you again.